Good morning to Miss. My name is Lu Aikin with matrix number 314685. And for today, I'm gonna present about the assignment 2 for questions topic 5 and topic 6, which is matrix and derivative. For Roman 1, we are required to write the system in the matrix equation, which is AX equals to B form. Matrix A is basically the matrix that formed by taking the coefficient of variable P1, P2, and P3, and X is basically the variable matrix which consists of P1, P2, and P3. For B is a constant matrix that consists of 12, 13, and 17. The second part, we are required to compute the determinant of the coefficient matrix of A. So by using the cofactor expansion along the first row, we obtain that the coefficient matrix is the value of coefficient matrix is negative 52, which is not the same as 0. That means that it's not a singular matrix. For part 3, we are required to find the adjoint of matrix A. First, we need to compute the minor of each element. Then we apply the cofactor signs, which is plus minus sign. After that, we need to arrange all cofactors into the cofactor matrix. Lastly, the adjoint of matrix A is obtained by doing the transpose on the cofactor matrix by rewriting the matrix from the row to the column form so that we can get the adjoint A. For Roman 4, we are required to solve for the vector of equilibrium prices. First, we need to get the A inverse matrix by using the formula 1 over coefficient A times adjoint A. After that, we should get a inverse matrix with 3 times 3 dimension. The next step is you use another formula to get the value of X, which is the equilibrium prices, P. By using a formula X equals to A inverse matrix times Y. At the end, we should get the prices for P1 equals to 7, P2 equals to 4, and P3 equals to 6. For Roman 5, we are required to verify the answer in P3 in Roman 4 by using the Cramer's rule. So for the formula to get the P3, the formula that we use is coefficient of AI divided by coefficient A. We use the coefficient A that we get earlier, which is minus 76. And after that, to get a coefficient AI, first we need to create a new matrix by replacing the third column of matrix A with the constant matrix that we created earlier, which is 12, 13, 17. After that, we try to get a determinant of it, and we should get the value of the determinant of A3, which is minus 456, which is the non-singular. After that, we need to use the minus 456 divided by minus 76, and we should get the value which is the same as the Roman 4, which is 6. For topic 6, derivative, for the question 2e, we are required to find the derivative of the following functions. So for these functions, we are going to use the chain rule to derive it. But before that, we need to rewrite it in the power form, so it's easier for us to do with it. So the first step, what do we do is, first we need to times the power to the function, and after that, we need to minus the power of function by 1. And next, we should differentiate inside the function, inside the bracket, so that we can get the value of it. For Roman 2, we are going to use the product rule and chain rule for exponential function to derive it. The first part in the product rule that we apply is the x squared, and the second part is the e power of 3x. And we need to follow the functions so that we can get the actual answer for it. For question 2D, we are required to find the second derivative of the function. For the first derivative, for this function, we need to use the chain rule for logarithmic function to derive it. First, we need to differentiate inside the function of the loan. After that, we put the function that we have differentiated on the upper part of the quotient. And for the second derivative, we are required to use the quotient rule as it is a quotient form, so that we can get the exact answer. For the extra question, extra question 1, we are required to use the product rule to get the derivative of the function, as there's two brackets over there that shows that it requires us to use a product rule to get the answer. And there is a e power of 4s over there, so that we need to use a chain rule for exponential function to derive it, follow the formula. For question 2, we are going to use the chain rule to derive the function. But before that, we need to rewrite the function in the power form, as there's a square root over there. After that, we follow the steps in the chain rule to get the answer of it, and we write in the quotient form, and that is the power of negative 1 over 2, and we need to write it in the positive form and not in negative form for the power, so that we need to write on the bottom.